Hi, I am Bernadette Venter-Stefik, and this is Katie Andre, and we are here to explain Newton's three laws of motion. Now, I am going to start with number one. Now, in my words, Newton's first law of motion is that every a object in a state of motion will stay in motion, and a object at rest will stay at rest until other forces act upon it. And now Katie is going to explain what that means in an example.
Hi guys, I'm Katie. So I'm going to give an example of this. The most common example used is a ball. Now, if a ball is sitting here at rest, it will stay at rest until an object force, like a hand, pokes it, and then in that case, it will move, like this. And it will keep staying at rest until forces of friction and gravity act on it.
It will keep in the state of motion.
Yeah, it'll stay in motion until friction, which will actually be going this way because the ball's going that way. Friction, gravity work upon it. But if those forces didn't exist, the ball would keep moving. So yeah. Okay. Now I'm going to explain the second law of motion in my words. Now, the second law of motion is essentially the equation force equals mass times acceleration. Mass being the weight and height and the general stuff of it, and acceleration being acceleration. And so that's essentially what the second law is. Here's Bernadette with an example.
An example of Newton's second law is such like let's see, like the ball that we were just talking about. Now, F would be the hand that pushed it. Oh, man. Would be the hand that pushed it. Now, the hand would equal the force. And then the force is acted upon in this direction upon the ball. Now, the ball is the mass. Now, it is mass. I guess some people would say as weight, but more as the content of the object. And acceleration is going to be at what speed, and the climbing of the speed that the ball is moving forward at. So depending on how much force the hand gives and how much mass the ball has, can be equal to the acceleration that the ball will then have after the force is acted upon it. But this can also, you can find out how much force the hand is giving if the equation is like such at the top, when if you have the acceleration and you have the mass of the ball, you can find out the force. And then, of course, you can figure out the mass if you have the force and acceleration. And now to Newton's third law. Newton's third law is actually quite simple in thought, or in words. It says, for every action, there's an equal and opposite reaction. But it's a little bit more complicated than just that. Here's Katie with an example. Actually, let me explain that first. That means that, like, if, for every action, like, the ball being pushed, there is an equal and opposite reaction. So there's an equal action of the ball being pushed forward, but there's going to be an equal and opposite reaction of force upon the hand that originally pushed the ball. So it's everything, and anything and everything is affected by this law. Even gravity. Gravity is being pushed upon. You are being pushed upon by gravity, but there is an equal and opposite reaction going the opposite direction. And now here is Katie with an example.
Alright, so an example of this is if you've ever been on a dock and there's a boat here, like this, if you ever stepped off a dock or off of a boat onto the dock, you will notice that the boat drifts away because your force, or your lack of force, pushes the boat away when you put your weight onto the dock. So, yeah.
So Just to add on what Katie said. So, if you would just want to see it in arrows, which makes more sense to everyone, is that your action of stepping on to the dock, there is an opposite and equal reaction of force being put upon the boat in the other direction, and that is why it drifts. Okay, and those are Newton's 3 laws of motion. I hope you enjoyed that, Mr. McNeil. Thank you.